What is the force of gravity between 2.5 if their centers are... Okay, it's the same problem, right, as the first one. Let's just try it again. Let's see if we can... So if we're going to use this formula, right, force is G m1 m2 over r squared, right? And then the key things to not forget are the squared, that's squared, and that's 6.67 times 10 to the minus 11th Newton meters squared per kilogram squared. And I'll show you what those units do in a second here. And then I'm going to call this M1. I'll call this M2. I'll call that R. Okay. All right, so let's just plug into this formula. So the force is equal to 6.67 times 10 to the minus 11th Newton meters squared per kilogram squared. I'm just putting the units in. I never do, but you know, we're just learning this. So 2.5 times 10 to the 14th kilograms, and then the spaceship is 48,420 kilograms, right? And then wingy, and then it's 5,000. Oh, that's cool. I've never done that before. 5,580 meters, and then that's squared. So look, if you look at the units, right? Kilograms and kilograms cancel kilograms squared, meters squared cancels meters squared, and we end up with newtons as well. We should, right? So 6.67 second E. So instead of going, you don't go times 10 to the minus 11th. You just go E. Second E, not the letter E, but the double E button, right? Minus 11 times 2.5 second E. On the TI calculators, it's a comma, right? Second E, 14 times 48,420. Oops, I almost didn't put a 0 on there. Divided by 5580 squared. And I get 25.93. Ta-da. Okay, so again, the two key things are make sure you square that, right? Well, baby, square that thing, right? Everybody forgets to square it. I don't know why. Okay, and then G, this thing is this is 6.67 times 10 to the minus 11th and not 9.8.